Welcome back to our double linked list. In this video, we are gonna go ahead and rotate the order in which the information inside the node is gonna be printed. So just to give you a quick example of what's gonna happen in this video, we are gonna go ahead and start moving the root. So numbers are printed in different orders. So the way that we're gonna do this and the result that we want is the following. So the first rotation, which we're going to just call rotation 1, is going to print 3, 1, 2. So as you can see, this was the previous print that was happening. It was printing 1, 2, 3. Rotation 1 is going to print first 3, then 1, then 2. So root is really moving its reference over here instead. So root is moving its reference right here. And because the way that we implemented the print node function is always going to look at the next node. So this will be rotation number 1. Then if you want to do more rotations, so for example, rotation number 2 will print 2, 3, 1. So once again, we're going to move this root pointer from here to here. And this is what it's going to get printed 2, 3, and 1. If you want to rotate it one more time, it's going to go back to the normal state or the original state that it was in. So rotation number 3 will be, of course, 1, 2, 3, and root will get moved to reference this right here, and no longer this node right here. So we're going to go ahead and jump into the code and make this happen. This is going to be pretty easy to do. So one of the first things that we want to do is call the function rotate inside our main function. And if we want to see the results before and after the rotation, we're going to leave that print node right there, and we're going to go ahead and print after. So we're just going to go ahead and call this function rotate node, and we are going to send it a reference to the root as well, because that's the way we're going to be accessing all the nodes in our linked list. So what we have to think about is, what do we want to return here? So what we really want to return in this case is a reference to the root, of course, because that's what's going to get moved. So we are going to go ahead and set up here the prototype of our function. So we want a pointer to a list, since we're going to return just that. And we called it rotate node, and also has a argument of double pointer to a list. And so here's a prototype of our function, and we're just gonna go ahead and declare this at the bottom of our program right here. Alright, so the first thing that we're gonna do is just create a reference to the root. So basically the same thing that we were doing before when we were iterating through the nodes to print them. We're also going to have a reference as well. So it's going to be a pointer, previous node, which is going to point to this node right here, and this is how we're going to be moving throughout our linked list. So we're going to create just that. So pointer to a list, and we're going to call it previous node. So now what we need to do is set up the previous node to point exactly the same thing as our root previous. So previous node is going to be root. So whatever root is pointing to, and then the previous of that node. Alright, so what just happened here was that we moved not only to point here, actually, we're looking at root is pointing here, and we're moving the previous node not here but to here. So the way that we're going to do that, we'll move this just a little bit here. So root previous, so it's going to be our 3 right here. So we're going to actually go ahead and remove that, which is really not going to point there at all in this part of the program. And we're saying that we want previous node to be pointing to this right here. Okay, so the next thing that we want to do is move the reference to the root wherever the previous node is pointing to. So we're just going to go ahead and draw it out here. So we're saying we want to move root to previous node, or whatever previous node is pointing to. So root is actually going to point here. And we are removing that reference to the first node by doing so. And we're just going to go ahead and do that as well. So we're going to say whatever root is pointing to is now going to be whatever previous node is pointing to. And now what we're going to do is just returning the reference to the root. So here's what we're going to return. So at this point, we are going to go ahead and call print node again, and we're going to see if it changed or not. So in this case, we're going to go ahead and recompile everything with all the flags that I mentioned in the previous video, just to check for errors and then be more specific, extra, and pedantic. And of course, the for program, so no errors, that's good, and A that out. So the first thing that it's going to ask us for is, of course, the size and how many times we want to rotate. We haven't coded this part yet, but we'll get there shortly. So we'll do 3 for the size. That's how many nodes we want at this point. And that's going to be considered in this for loop right here, how many times the scanf function is going to be called and how many times we want to rotate. And then we're going to put the numbers that we want in our nodes here. And as you can see, the first time that we call print node is 1, 2, 3. The second time that we come print node is going to be 3, 1, 2. What changed was that rotate was in the middle of those two, and we rotated our numbers successfully. So now we're going to go ahead and jump into how many times we want to rotate. So for this, we can just use a for loop. And we can even use the same I variable that we're using for the previous one. So we are going to initialize I to 0 again. We're going to say, well, I is smaller than rotate, because those are the times that we want to rotate. And then every time that this happens, we're going to increment I by 1. So in this case, we're going to put the rotate inside our for loop right here, and we're going to see what's going to happen in this case. So we're going to go ahead and compile this time again because we made some changes, no errors, that's great. Execute the program. It's going to ask us for the size. So let's say we want 3 and we want to rotate it 2 times. We want again 1, 2, and 3. So as you can see here, before any rotations happen, we are going to print 1, 2, 3, the original input into the linked list, and after rotating 2 times, we have this result right here. So you can do the same thing with 3 times. So let's say 3, 3, and 1, 2, 3. So we're going to have the same result. So without rotations and after 3 rotations. So we're going to go ahead and print something else here. I'm going to use a printf just to distinguish how we're printing things. So we're going to just say before rotations, And then we're gonna go ahead and say here after rotations. In this case, we're just gonna see all the times, all the changes throughout the rotation, so we can see everything. And I'm also just gonna print a line here to separate things so it's more clear for us to see. So just that and a new line. So let's compile this program, check for any errors that we might have. No errors. Let's run the program. So once again, size 3, how many nodes we want, and we want to rotate 3 times. And we want our numbers to go inside the nodes so we can see before rotations, after rotation 1, after rotation 2, and after rotation 3. Okay, so that is it for the program. I'm going to have a link for this whole code, and I'm going to add more comments so it's more clear. And it's going to be a link to my GitHub. If you like this video, please subscribe and like it.